Thursday night, COMP1400, or Infosys 1609, Infosys 2609, any other people who might be happening to turn up. So what I'm going to do tonight is go back over a fair bit of the stuff that we actually talked about on Tuesday, because I felt that Tuesday's lecture was, well, I prepared it rather badly, I was rather rushed, and then I kind of got a bit messed up and didn't explain things as clearly as I'd like. And but also on Tuesday's lecture, an awful lot of people were talking, and that's probably because I was getting lost, you were getting lost, nobody knew what we were talking about, and everyone started chattering. But it really made life hard for the people who were actually trying to pay attention rather than the people who had tuned out. So I will ask in future, and I'll reiterate this on Tuesday because more people seem to come on Tuesdays, that please shut up in lectures. I will try to remember to tell you to shut up in lectures if you start talking. But if you do want to hang around and talk, please hang around outside and talk. Lectures are for people who are listening. Outside is for people who are chatting. I like making these lectures informal. I don't want to be here as the draconian lecturer who always tells you, either you shut up or you get out of my class. But either you shut up or you get out of my class, all right? Seriously. Not for my sake, because I don't really care. It doesn't, you know, I get a little bit upset if you're not paying attention to me, but I can understand if I'm boring, you don't care. But there are people here who actually do care, and so for their sake, shut up and let them listen. And yeah, I'm happy to lecture to, if my lectures are boring, I'm happy to lecture to a completely empty room and you can watch them all on video. But I think there's something worthwhile being here, so if you want to be here and listen and keep your mouth shut. Unless you have a question, in which case, stick your hand up and ask a question. And if I do start, I mean, I realised that Tuesday's lecture was kind of unclear. I was not prepared enough. And if I do get into that state, please stick up your hand and say, I'm sorry, look, you're going too fast, or I didn't understand that bit, or can we back up? Because I'm only here for your sake, for you to learn stuff. I don't just want to stand here and talk for my own sake, because that's kind of dull. I can stand in my office and talk. So we're going to go back over lists, and hopefully I'm going to be a little bit clearer this time. I spent a little bit more time trying to make this understandable. But hopefully we'll get through it quickly enough to go on to some stuff that we didn't get to on Tuesday. So lists again. So like I said, an array list is a collection of objects of the same type. And this comes up again and again in our code, where you have a bunch of things. They're all more or less the same kind of things, but they all have slightly different variations. And you want to stick them in a list and talk about them as a group. And you want to be able to do things with them. You want to be able to look at them individually. You want to be able to iterate through that loop and do operations on all of them, and a number of other things you might want to do with lists. So Java provides us with a bunch of different ways of dealing with collections of things. An array list is only one, and an array list is specifically a list of objects that is ordered, indexed, and variable length. So ordered means that the array list provides a specific order on the object. So there's the first object, the second object, the third object. Indexed means that we actually give them numbers. Because they're ordered, we can number them. And variable length means that it can grow and shrink as we add and delete objects from the list. There are other kinds of collections which don't have this. Arrays are fixed length collections, so they're ordered, indexed, fixed length. Sets are actually not ordered. Sets or indexed, because a set is just a group of things. And so if you have a set of things, it's just those 5 things, and there's no order to them and nothing like that. And there are various other ones that we'll encounter along the way. But the list is the most common thing that you'll be dealing with, and so we'll be talking about lists. Okay, so when we're declaring a list, like I said, an array list is a list of things of a certain type. But the nice thing is that every array list can be a list of things of whatever type you want. So we don't, rather than having a specific list of integers and a specific list of strings and a specific list of whatever, we have this general idea of an array list, and then we have the way of telling it, okay, this time I want a list of strings, or this time I want a list of integers, or a list of books, or a list of cars, or a list of tickets, or whatever the things are in the list. And so the array list does the same thing for all of those classes, but we need some way of telling it what kind of list it is. And so this is called a type parameter, and here so we have the collection class, which is array list, and then we have inside these angle brackets, we have the item class. And so all the items on an array list string are going to be strings. All the items on an array list integer are going to be integers. All the array list items on an array list book are going to be books. This is good because this is actually another example of abstraction, because the way a list works doesn't really depend on the things that are in the list, right? A list of books is the same as it works the same as a list of strings, works the same as a list of integers. So the array list is a general idea of a list, but then we can parameterize it by telling it exactly what kind of list we want. We want a list of strings in this case, and so we call it array list string. So if we're declaring a variable that is a list of strings, this is how we do it. We say array list string list of strings, and now we've created a new variable, and that variable contains a list of strings. Or we could have a list of ints, or we could have a list of books. A specific thing to note here that I said before, but it's worth going over, is that we can't have an array list of ints for a little I int, because you can't have an array list. Array lists only apply to objects. They don't apply to primitive types. So we can't have an array list of ints, but we can have an array list of capital I integers. So Java provides us with this. This is a class called integer, which just represents a single integer. So it really is just an int wrapped in an object. The nice thing about it is Java provides a shorthand so that we can translate between big I integers and little I ints really easily. So we can take, this is an int, we can assign an int to a variable that's an integer, and it'll automatically create an integer object out of that int. We can take an integer object and assign it to a variable that's an int, and it'll automatically strip away the object and just pass around the int. So for the sake of what we're doing, big I integers and little I ints are almost completely interchangeable. The only issue is that sometimes we need an object. And then specifically when we have a list of things, the things on the list have to be objects. So when we need an object, we use big I integer. When we don't need an object, we'll just usually use a little I int. Most of the time you will use little I int in your code, but when you have to stick it on a list, you've got to do this. This is ugly. Most programming languages get around this and don't force you to do this. Java, unfortunately, you have to do this ugly little bit of hackery in order to make things work. It makes your code less understandable, but that's something you're going to have to live with because Java is the language you're using. C#, which is a sort of Java on steroids, which came out of Microsoft, has nice ways of getting around this, but unfortunately, we're not programming in C#. We're programming in Java. Go figure. Every language has its little ugly bits, and this is one of Java's. Okay, so that aside, if we're just dealing with array lists of objects, first of all, we need a way of creating a list. Now, a list is another object, like any other object. And so we can define a variable to be an array list. Here we're defining the variable class role to be an array list of strings. And we're using a constructor on array list to create a new instance of that class. So array list is the class, and we're creating an instance of that class. So we're creating an object. So so here we're beginning to get into. So far, all the objects we've been thinking about have been really concrete things, like a car, an engine, a ticket machine, a ticket. So our objects have been things that we can recognize in the world. Now we're starting to approach objects which are more abstract things. A list is a kind of object in our code. And a list is, it's not really, I mean, yes, you could imagine a sheet of paper with a list on it and it being a concrete thing. But now we're beginning to create objects to represent functionality in our code that doesn't really represent a thing in the world. So this is, so we're going to get more and more down that line. As you program, you're going to start creating objects that are just an important piece of code that goes together to perform some function. And a list is an example of that kind of thing. A list is a concept in our code rather than a thing in the world. But it's a useful concept to have in our code, and so we can create an object that represents that concept. Okay, so ArrayList is a class, and like any class, we create instances of it by calling a constructor. You can look in the API documents for what constructors it has, but almost always you'll be using this constructor, which is the empty, has no parameters, so it's the parentheses are empty, and this creates an empty list, a list with nothing in it. And this is how I'm going to show that. This purple thing over here is our list. At the moment it has nothing in it, and so we say its size is 0 and there are no elements in that list. So it's a list with nothing on it. And this is commonly how you'll start out when you're doing stuff with lists. You'll start with an empty list and then you'll stick things on it. And so to add things to a list, we'll mostly use the add method. It's a pretty normal way of adding things. Our class role is a list of strings, and so we can add some strings to the list. So we add Malcolm to the list by calling the add method and passing it Malcolm, and we add Claude to the list by passing it the parameter Claude. I should say right now, I'm going to mix up the words parameter and argument. Formally, the parameter is the variable in the method definition, and the argument is the value you're putting into that variable. But programmers tend to use those words kind of interchangeably. So if I say that Malcolm, I can either say that Malcolm is a parameter to this method or Malcolm is an argument for this method. I really mean the same thing. So if ever that gets unclear, I'm more or less using those two words interchangeably. Add is a method that has one parameter or one argument. I don't know where those names came from, but they've been around forever. So when I'm not thinking, I'll use one or other of them without being clear that I mean both. So we have because the class role is an array of an array list or just a list of strings, we can add strings to it like this, and what we get is now this purple thing over the side, which is a list with two items on it. The first item is Malcolm, the second item is Claude. And notice that if we do them in this order, that every time we add things, it gets added to the end. So add sticks a new element on the end of the list. We can add as many things as we want to the list. We could keep adding names, and every new name would be tacked on to the end of the list. We can't add things that aren't strings. So for example, if we try to add 47, 47 is an int, not a string. Even if we convert it into a capital I integer, it's still not a string, it's an int. So we can't add 47 to the list, and that would cause an error. So the type of the objects we add must match the type parameter for the list that we're using. So if it's a list of strings, we add strings. If it's a list of books, we add books. If it's a list of whatever, we add whatever. We can add things multiple times. If I take the class role we just had and add Malcolm twice more, it adds Malcolm 2 more times on the end of the list. So one of the things to note here is that lists can contain duplicates. The same object can be on the list several times. And what's more, I can actually draw this. Let me draw something. Where's my pen? Is this one going to work? Okay. So if we were actually, rather than adding strings, if we were adding objects, so this is, say we're adding books to a library, this is the book, and its title is, what's a good book? Name a good book. Anybody's favourites? I'm going to say Moby Dick. I don't know why, it just came into my head. And this is another book here, and this book is called, any names? What's another book? I don't know, who reads books these days? Sorry? Okay. I have no idea what he said, but I'm going to write down Lord of the Flies. I don't think that's what he said, but it's what I heard. So there we go, that's another book. Strange books. I've not read either of these books, so go figure. Then if we have our list, if we add this book to the list, so this is our list, our array list of books, right? And one of the things that I always accidentally do is say array list books, plural, but it's not books, plural, it's book, because of the name of the class is book. So you'll see I make that mistake fairly regularly. So if we add that to the list, then what we have here is a reference pointing to that object. So you got to remember, anytime we have an object, what we actually have is the object sits out here floating in empty space, and the thing on the list is a reference to that object. And then if we add another object, if we add this object, we have a reference to that. Now what we can do, if we add that first object again, we'll actually have another reference pointing to the same object. Now the reason why this is important is if I do something like, if I find this element here, right, and I change this title from Moby Dick to Wind in the Willows. I've suddenly decided to rename Moby Dick into Wind in the Willows. This arrow still points to that same book, right? And so this entry will look like will be Wind in the Willows as well. So every time, so what we've got on here is not, we don't have book objects on the list. We have references to book objects. Everywhere that we have a variable or a field or anything that contains an object, what we really have is a reference to the object. The object itself is floating out there in space, but we have an arrow pointing to that object, which gives us a way of finding that object, essentially. So if we have that object on here twice, and we change, if we assign a different value to this spot, we can actually change the arrow to point to there. But if we follow the arrow and then change the title, we're changing the thing that is being pointed to, and so it's this thing is being pointed to, and it's also being pointed to there, so we're changing both of those things in a sense. There really is only one thing, but there are two things pointing towards it. It's a bit tricky to get your head around this referencing thing, but the idea is that you never have an object in another object. You have an object out there in space, and then this other object refers to it. And if two objects are referring to the same thing, then if one of them changes it, the other one sees that change as well, because it's referring to the same object. So it's like, you know, if Frank is your friend and Frank is my friend, then if I go and punch Frank in the nose, I've changed Frank. Your friend Frank has also been punched in the nose, because they're the same person, right? They're not different people. There's not like suddenly my friend Frank has a bloody nose and your friend Frank is fine, because they're the same person, right? So always think of these things as references. Yes?
So how does that work when you have an integer? So if you have an integer...
Okay, so yes, that's tricky. If you change an integer, if you have so that is weird, and this is why I really don't like the way Java does this auto-boxing thing. The integers are weird. So if what we had actually was, if this is a list of capital I integer, then over here we'll have an integer, and inside it'll have a value 1, and over here we'll have an integer, and inside it'll have the value 2, and this one will be pointing to that one, and this one will be pointing to that one, and this one will be pointing to that one, right? And so effectively we've got the list 1, 2, 1. The thing is, this is, you can never change the number inside an integer object. If I now assign a new value to here, if I put 3 in there, what I'm not doing is I'm not putting 3 in this box, right? That's wrong. What I'm actually doing is if I assign 3 to there, I'm actually creating a new integer object on the fly with 3 in it, and then I'm putting a reference to that there. So that's the one case where you're breaking the rules, right? In that if you're not actually changing what's inside the object, you're creating a whole new object when you do that. And that's why I don't like the object wrapper thing, because it does things that are kind of nonsensical, or it breaks the model, because the model is always otherwise that there is a single object there. But in this case, it automatically creates a new integer object and assigns that in there. So basically, Java creates integer objects on the fly when it needs them, which is a bit messy, but yeah, it's what you got to live with it. Yeah.
So if you had a third variable in your list, which was 3, would it then create another integer?
Yeah. So if we create another thing called 3, it'll actually create. Well, actually, it's not even apparent. It's not even explained, right? It's not even explained whether or not this 3 would also point to this 3 or there another 3. The same thing happens with strings, actually. In fact, an important difference in strings is that in this case, these might both point to the same string Malcolm, or they might point to separate strings Malcolm. If we just create an anonymous string like that in Java, it creates objects. The strings are actually objects, but these might be two different objects, both called Malcolm, or they might both be the same object called Malcolm. Java might be smart enough to reuse it or might not. It's not actually defined. Most of the time that doesn't matter. There are a few rare occasions where that matters. Particularly if you're checking whether two strings are equal, it matters. Because if you're using the equality thing, and this is going, well, if you don't understand this, don't worry about it. But if you're using the equality test, if you use the equality test on two objects, it actually says, are these the same object? So if you say, is object X equal to object Y, you're saying, are these both references to the same object? So if I've got one variable pointing to here and another variable pointing to there, then they would be equal. Now there's another sense in which two strings can be equal, which is they represent the same string, but they might be different objects. There is actually a method on the string class to check whether the two of them have the same value. So there's a difference between, later on you're going to find, you're going to do a test to say, does this string equal that string? And you'll find that you'll get the answer no, even though they appear to be exactly the same. And the reason why you get the answer no is that Java has two different objects, both representing the same value. And by doing the equality operation, you're actually asking, are they the same object, not are they the same value? What you've got to do is use the is equal method to check whether one string is equal to another string. It's messy, but it's an important distinction. If you didn't understand that, and there was a lot of hand waving, don't worry about it. We'll get to that later. All right. So anyway, how are we going? Good. Okay. So every list has a size. The size is updated as you add things, and there is a size method with which you can use. It's an accessor method with which you can get at that variable. So if we start out with this list with Malcolm and Claude, it has size 2. So if we call classRoll.size, if we call that method, we'll get back the value 2, which will go into new n students, and n students will be 2. If we add sim to the list, then the size of the list is now 3, and if we call classRoll.size, we'll now get the value 3 back, and that will be the new size. So the size automatically tells you how many things are on the list. Very easy. If we want to get things off the list, or if we want to read the list, usually we use the get field, the get method. The get method will return the item at a particular index. So get 0 returns item at index 0. So index 0 is Malcolm. Index 1 is Claude, and so get 1 returns Claude. So the important thing to notice here is that we start counting from 0. And we end at the size minus 1. And so if there are 3 things on the list, get 0 returns Malcolm, which is item 0 on the list. Get 2 returns sim, which is item 2 on the list. Get 3 gives you an error because there is no item 3. It's just one of those weird things about computer scientists. It originally started out is you were at the front of the list, and then you asked, how far do I have to move before I find the item that I want? So if I'm at the front of the list, Malcolm is right there, so I have to move 0 steps in order to find Malcolm. If I want to find Claude, I have to move 1 step, and so he's item 1. If I want to find Sim, I have to move 2 steps because she's item 2. But that's just a weird historical fact. What it means now is that computer programmers just always count from 0. Go figure. It's one of those things that makes us special. and allows us to laugh at people who don't understand. So when we can remove things from the list as well, and there's a remove method. The remove method asks us for an index, and the index the item of that index will be deleted. So if we remove item 1, hey presto, Claude gets deleted. The list gets smaller, so the list is now size 2, and sim items after the one we deleted get renumbered. So Malcolm is still item 0, but sim is now item 1. Because there are only 2 things on the list, they must be numbered 0 and 1. So the numbers, the indices of things are always 0, 1, 2, 3, up to the number of items in the list minus 1. So when we remove things, we renumber, we shift everything up. There are a bunch of other methods in the API documentation that you can read for yourself. Some of the ones you might want to check out. The clear method will remove everything from the list, and so it will leave you with an empty list again. The set method will actually let you set the value at a particular place to replace the existing value there. So if you've got Malcolm, Claude, Sim, and you want to replace Claude with Morgan, you just say set item 1 to Morgan, and it replaces that. The insert method actually inserts an element and then shifts everything down. So it does the opposite of remove. So if I insert something at 0, then I get a new name at 0, and then all the elements after 0 get moved down. There's a contains method which you can use to check if something's on the list. There are a lot of other methods on this class that do various things that you might want. I'm not going to go through them all. That's what documentation is for. And one of the important things to note at this point is that documentation, like the API, is essential for programming. You'll refer back to that documentation all the time, so get used to how to learning how to navigate it. In particular, I mean, I still use it on a regular basis in order to look these things up. In particular, for this subject, I don't expect you to memorize the documentation, right? I don't memorize the documentation, why should you? So in the prac exam, in the final exam, we will give you access to the documentation in order to look that stuff up. So if we expect you to use a class like the string class or the array list class or whatever, we'll give you the API documentation. So it's not important that you memorize all these methods. It's important that you learn to read the documentation and understand how to use it. You should be familiar with the methods so you know which one to look for. So hopefully you know what's on an array list that you can use to do what you want. But you don't need to memorize the exact details of everything. I had to look up the documentation just to write this slide. So and so yeah, a lot of stuff. I'm not going to, and in general in this course, I'm not going to have time to give you all the details of everything. So I'm not going to have time to tell you all the different Boolean expressions or all the different methods on this, that, or the other. That's what documentation is for. Hopefully I'll be giving you enough information to understand how to use things and to know what to look for and where to look for it. But there are a lot of little details about all the math operations that you can do in Java, and I don't want to have to explain to you how to do all manner of different things in Java. You can look them up in the documentation. A lot of it is in the API. So go have a look in there if you want. And there are some good Java tutorials on the same site as the Java API. There are some good Java tutorials which will run you through exhaustively everything that Java does. Hopefully anything that I expect you to use in your assignments or in your tutes will be explained before we do it. But sometimes you'll have to go looking in the documentation to find things out. Go figure. All right. So in the time remaining, I want to start talking about loops again and the different kinds of loops we can do. So very often in our code, we'll want to do the same operation multiple times. And it gets quite repetitive if we have to write out the code several times in order to do that. So if we wanted to print out all the names on the class roll, this could be one way of doing it. We could get item 0 and print that. We could get item 1 and print that. We could get item 2 and print that. We could get item 3 and print that, and so forth. If we changed our minds and decided to print them out with some different formatting, I'd have to go through this list and change each one of these entries in order to change the formatting of how we're printing that out. That would be really tedious. And so one of the things we like to do is avoid duplicated code. If we've got the same code in several places in our program, generally we'd like to find a way of making it so that we have that code only once and we reuse that code. In this case, the reason why we want to do that is, well, first of all, it's tedious to write this out a zillion times. Secondly, if we ever want to change the code, we'll have to change it in every single place that it's written, so we want to write it fewer times. Thirdly, in this case, we don't actually know how many times we're going to do this. Depending on how many people are on the roll, we might want to do this 1 time, 5 times, 10 times, or no times. If the roll is empty, we don't want to print anything. And if we don't know that in advance, we can't write out as many commands as there will be people on the roll. So what we want to do is to make the computer the computer knows how many people are on the roll. We want to make the computer print all of them and just say, keep doing this until you run out of people on the roll to print. So a loop is a way we can do that. A loop says, do this same operation multiple times until you've done it enough, for some definition of enough. And there are different kinds of loops which have slight variations on that. So there are for each loops. For each loops are specifically for when you have a collection of objects, like an array list. It allows you to do some operation on every item. So you look at the first item, you do an operation on it. You look at the second item, you do the same operation on that. You look at the third item, you do the same operation on that, until you run out of things, and then you keep going with whatever happens after the loop. A while loop is for when you want to do an operation until some condition changes. So a while loop is kind of like an if statement, but an if statement inside a loop. And so if something's true, you do some operation. Then when you finish the operation, you come back and you decide, do I want to do it again? If it's still true, yeah, I do it again. And if it's still true, I do it again. And if it's still true, I do it again. Until it becomes false, and then I do something else. A for loop is specifically if you want to do an operation a specified number of times. So if you want to do something 4 times, you would use, well, that's a coincidence. If you want to do something 5 times, you would use a for loop. It's not F-O-U-R, it's F-O-R. You would use a for loop to do it, and you'd say, do this operation 5 times. And it would do it once, twice, 3, 4, 5 times. Okay. So in detail, what that means is a for each loop looks like this. It's used to iterate over items in a collection. And what we have is we have this keyword for, and then in parentheses, round brackets, we have the name of the type of thing on the list. So you want to shut up down the back corner. I told you I would tell you to shut up. That's been due. Thank you. And so this is an array list of strings, and so each of the items on the list is going to be a string. So the first thing there is we need to say what kind of things are on the list, strings. The second thing is we have a variable which we're going to use to look at each element. So this variable is when we're getting elements, we're going to be putting them in this variable so that we can look at them. So we're going to pull names off the roll, and each time we pull a name off the roll, we're going to stick it in this variable and do something with it. Then we have this colon in the middle, and then the last thing is a list variable, which is where we're getting things from. So in this case, this is the class role, which we've defined already. So this has to be something, a list that we already have that we're pulling objects off of. So let's have a look at that in action. So let's open up a BlueJ. Let's create a new class. We're going to call this a role. And we're going to create a field. Actually, we're just going to, I'm not even going to create let's create a field. Let's create a private. It's going to be an array list of strings, and it's going to be my role. Okay. Actually, let's call it my names, because it's going to be a list of names. And that makes it clear. And then we're going to have a constructor, so public role, and we don't need any arguments. And we're going to have use the array list constructor, so new array list, and it's an array list of string, and we're just going to use the standard no argument constructor. And now we're going to take that new array list that we've just created, and we're going to stick it into the myNames variable. So myNames equals array list. One comment, in tutes, I've noticed a number of times people getting this around the wrong way. In particular, if there's an argument here, say let's put in string, I don't know, string title, and we have here private string my title. Okay, if we want to copy the title into my title, a lot of people seem to be writing this. Okay, that's round the wrong way. Okay, don't do that. That says take the value out of my title, which is currently null because we haven't put a value in it, and stick it into title, which is the parameter, and we're going to throw that variable away. That doesn't work. Remember, it's always the thing on the left is the destination, the thing on the right is the source, right? So my title equals title. That's correct. So all the stuff on the right is the value that we're creating. We're taking that value and sticking it into the thing on the left. Try to remember, in some languages it's a bit clearer because they actually use a little arrow like that which points to the left. Whoops, an arrow like that which points to the left. That's kind of clearer. It means what's happening in title gets stuck into my title. Unfortunately, because for historical reasons, we use equals in Java because equals was used in C probably years and years ago. But what you've got to think is that it's the right-hand side is being put into the left-hand side. So it's always an arrow pointing left. In your mind, it's an arrow pointing left. Okay. I just noticed people were doing that a lot in tutes, so just make sure you don't do that. So here we're using the constructor to create a new array list, and then we're sticking that into the myNames list, names plural. And now what we're going to do is make a method to add things. So we're going to say public void add name, and I'm going to take a name, so string name, and I'm going to add that name to the myNames.add name. Right? So it's a simple mutator method that asks you for a name and takes that name and adds it to the myNames list. So every name we get, what is that noise? Every name we get, we stick it on the end of the myNames list. Okay, so that's perfectly fine. But what we know I want to do is print out the role. So we're going to add a print method. And now to print out the role, we actually want to print every name in sequence. So what we're going to use is a for each loop. We're going to say for every, and now the things on the list are strings. We're going to have a variable called name to put those strings into, and we're going to take them out of myNames. And we have the in then embraces the body of the for statement. And what we're going to do is system.out.println. We're going to print that name variable. Okay. So what this is actually a local variable definition. In fact, this variable only exists for the body of this for loop. So where before we had variables which were thrown away at the end of the method, now we've got a variable which is being thrown away at the end of the loop. This variable is special because every time around the loop, a name is going to be taken out of this list and put into that variable. And so the value of this variable is going to change. It's going to start out as Malcolm, and then it's going to become Claude, and then it's going to become Sim as we go through the names of our list. So this is a convenient way of going through the elements on the list one by one. Then once we've got those variables, we can do whatever we like with them. In this case, we're going to print them out. So let's actually create one of these now. Compile, make sure. I made the classic mistake. I forgot to import java.util.arraylist. Okay, it's very important. Java ArrayList isn't a built-in part of Java. It's in the API, so it's in the library. If we're using anything out of the library, we have to import it, and so we have to find what package it's in. It's in the Java util package, and then we have to import, and then the name of the package and the name of the class. And I have it shoot in 15 minutes. So we import it, and hopefully now when we import it, it can actually find it. Yes, it gives us no syntax errors. And so now if we create a role, I still got that title string. Let's go back and remove that. We don't need that. Remove that argument. Oops, go away. Delete that. Compile again. Go away. Okay, so we're creating a new role. It's called role1. And now if we print that empty role, oh, it doesn't even do anything. So the console doesn't even appear because nothing got printed. So there's nothing on the role, so printing it does nothing. But let's add somebody to the role. So let's add another name. Let's add Malcolm to the role. And now if we ask to print the role, it'll print Malcolm. Cool. So let's add another name to the role. Let's add Claude. Can't find symbol Claude. That's because it's not a symbol, because I forgot to put the little divvy whackers around it. And let's add another name just for excitement. Let's add Sim. And now if we print, it prints all three names. Malcolm, the first name there, the first Malcolm is there, is from before, but it prints Malcolm, Claude, and Sim. Okay. Now let's actually come in here, open up the role again, and let's put a breakpoint here at the beginning of the print method, and actually look at what's going on. So now when we run print, it'll hit the breakpoint and open the debugger. And let's have a look inside. Oops, just done the wrong thing. Ah, stop doing that. Click there. Thank you. Okay. So now looking inside, we're inside the print method. So the call sequence says we're inside print, and the print method, it's print on the class role. There are no static variables. We don't know what they are at the moment, so don't worry about them. These instance variables, that's the fields, and so there's one field, and it's called my names, and it's an object reference, and BlueJ isn't smart enough to print out at the moment what that object is, but it's an array list. We know it's an array list. We can't see what's on that array list. Whoops. But now we go into the loop. If we press step, it starts doing the loop. So it's got into this statement here. It hasn't executed it yet, and it's created a new local variable called name, which is a string. So that's what we said here, string name. That local variable has been created, and that variable is initialized with the first value off the list. We step through, it prints out Malcolm like it's meant to, and goes back to the top of the list again. And now at the top of the list again, top of the loop again, shut up. Yeah, thank you. Does it again, and this time it creates the name again, and this time it initializes name to Claude, and it prints out Claude, and it goes back to the top of the loop, and it does it again, and this time name is Sim, and it prints out Sim, and goes back to the top of the loop, and this time it realizes that there's nothing left, and so it finishes. So it goes around that loop as many times as there are things in the list, and each time it assigns that sticks that value, takes the value off the list, well, copies the value off the list, sticks it into the variable name in this case, and then we do something with that name, and then when we're finished doing whatever we want to do, it goes back to the top of the list and does it again and again and again until it runs out of names. So that's a for each loop, and you use for each loops a lot when you want to do something on a list multiple times. If there's nothing on the list, so if we clear the class role, this will do nothing, right? Because there are no objects on the list. So it'll get to the top of the loop, check whether there's another object there. There's nothing on the list, nothing to do, it just keeps going. So a loop that has on an empty collection will do nothing, or a for each loop on an empty collection. A while loop is a different kind of loop. This is used to do some action and keep doing it as long as some condition is true. So for example, a real life example is if it's, I will keep walking until I'm out of the room. And so I'll say, okay, I'll take a step Am I still in the room? Yes, I'm still in the room. I'll take another step. Am I still in the room? Yes, I'm still in the room. I'll take another step until I get outside, and then I'll stop. So this is, so as long as some condition is true, keep doing this thing until the condition becomes false. So in this case, for example, if we started out with this angle variable at 735, and as long as the angle is greater than or equal to 360, we subtract 360 from the angle. This is the same as saying angle equals angle minus 360. It's just a shorthand. I think I've shown you that already. So as long as the angle is greater than 360, we keep going around that loop. So if I show you what that looks like in code, let's just write it here in the middle of any old method. I'll just write a public void convert, for want of a better word, name, int angle equals 735, and then say while angle is greater than or equal to 735, angle minus equals 360. Right, and now if I put a breakpoint on that, compile, will you? Compile. Oh, what are your problem? Int, oh, that's not an equals sign. Equals. Now compile. Thank you. That method has nothing to do with roles, but it'll do for the time being. We create a role. We call. Did I actually put a breakpoint on that? I don't know whether I did. Let's have a look again. If I put a breakpoint here, it's better. Now if we call on that role, if we just call that method that I created, we can run it. So we're here, we step, and we create an angle of 735. So we've got a new value. We test whether, oh, I've made a mistake. That shouldn't be, let me change that code. 360. Whoops. We recompile. Oh, I can't compile while running because you're annoying. How do I get out of the debugger? Oh, not there. View. Debugger. Terminate. That's really annoying. Well, it makes sense, but it's still annoying. Compile. Okay, compiled. Have we got that breakpoint? No, we set the breakpoint again. Okay, cool. Everything's happy. We create a role. So convoluted. Okay, here we go. Okay, so we hit that point. Angle is now, and we run that step, and angle is 735. We then test whether angle is greater than or equal to 360. Now 735 is greater than 360, so that's true. So we do the loop. We subtract 360 from the angle, so the angle is now 375. Right? We come back around again and say, is the angle greater than or equal to 360? Yes, it's greater than or equal to 360. We enter the loop. In the loop, we subtract 360 from there, and the angle is now 15. Now, is 15 greater than or equal to 360? No, it isn't, and so we stop. So this is kind of like an if statement. We say we do a test, and if the test is true, we do the thing. Except at the end of an if statement, we just keep going, whereas at the end of a while loop, we jump back to the top. Now, an important thing to notice here is that the test is only done at the top of the loop. So if I do this, angle plus equals 360, and we start with, say, 361, and we compile, and we have to go all the way around again, and it's going to complain about the same thing again. Debugger, stop. Oh, and I keep. This is Malcolm being annoyed. Okay. Compile, and I have to go back in here and probably again and set the breakpoints. And we create a role, and we call it role. And we come in here, and we call convert. Hey, finally. Okay, so angle is 361. 361 is greater than or equal to 360, so that's true. So we subtract 360, so angle is now 1. But now we add 360, an angle is 361, and now we go back to the loop and test this again, right? And now 361 is greater than 360, and so we go around again, right? So even if in the middle somewhere the condition becomes false, it's only tested at the end of every loop, or at the beginning of every loop, really, because it's tested the first time and it's tested every time after that. And so this loop, if we say continue, it'll happily keep going forever. And that'll go round and round and round, and it's just going around that loop, around a loop, and it'll always be true, and so the loop will go on forever. This is usually a problem. You usually don't want your code to just sit there running around and around in a loop, not doing anything. So that's probably bad. So when you design your loops, and especially while loops, you've got to design your loop so that you know it's going to terminate. And that's kind of tricky sometimes. You can't always be sure that a loop is going to be terminate. For loops and for each loops, you can generally be sure when they're going to terminate. While loops, you've got to be careful in your design, or you might make a loop that goes on forever. All right. Finally, back to the slides. So there's a while loop. Again, it's just while, and then in there a Boolean condition, so something that either evaluates to true or false, and then the body of the loop. If the condition is false from the outset, then the while loop does nothing. So if the angle is initially 90, then it checks is 90 greater than or equal to 360? No, it isn't, so it does nothing, and it just skips. So it's very much like an if statement, but an if statement that always jumps back to the top and does it again, and does it again, and does it again. The last thing before we all run away is a for loop rather than a for each loop. A for loop is used to do something a certain number of times. And the syntax for a for loop is kind of sophisticated, but basically there's a counter here, which we're going to, in this case, we're going to call that counter I, but the counter can be any variable you want. Usually it's an int. Almost always it's going to be an int, but you can be flexible. You can have other things in there if you want. You have some way of initializing it, so you set it to some starting value. Then the second thing inside there is a condition. As long as that condition is true, the loop will keep going. And the third thing is an incrementer, and the incrementer gets done at the end of every loop. So effectively, what this says is start at 0, keep going until you hit 5, and every time you go around the loop, add 1 to the counter. So it's going to go 0, 1, 2, 3, 4, then it's going to hit 5 and finish. It's kind of a bit hairy, but it ends up being actually a very simple way of doing a very common operation. The number of times you want to do something 5 times, 10 times, whatever, is very common, and so this is like a very succinct way of writing a loop that does that. This is actually equivalent to a while loop, though. But it's a while loop where, again, we have a counter variable, we have a starting value, we have a Boolean condition, and we have an increment. So effectively, this is a shorthand way of writing that. And the fact of the matter is that we write loops that look like this a lot. And so it's easier to do them in this shorthand way rather than doing them in this long way. One of the particular reasons why we do it this way is that if you why you do it in the compact form, is in the compact form, all the stuff to do with the counter is all in the head of the for loop, right? In the while loop, the stuff to do with the counter, the stuff to do with the counter is all over the place. There's some in the top and some at the bottom and whatever. If you write this, and 9 times out of 10 you'll forget the incrementer. And you'll wonder why your loop goes forever, and it's because you start out with the value 0, and you check 0 is less than 5, and then you go and you do something, and you come back to the top, and it's still 0, and 0 is still less than 5, and so you do it again, and again, and again, and your loop goes forever, with I forever equal to 0. This is just human forgetfulness, but there are so many times I've done that. When I've written a while loop that needs an increment action, you leave it off. So the idea behind the for loop is really just to make a shorthand form where we stick all of that together in the head, and so we don't forget. So really they're the same. They do exactly the same thing. So you'll never need to use a for loop. You can always use a while loop to do what you want, but a for loop is a more convenient way of doing it. And for loops can be done, you don't have to have it counting from 0 to 5. You can, for example, have it counting from 0 up to the size of the class roll. So this says start at 0, keep going until you hit the class roll size, and every time add 1. And this is a convenient thing. You'll see this a lot, especially in for loops. I++ is a shorthand way of saying I equals I plus 1, in other words, increment the value of I. Basically, we do this so often, we have a short way of doing it, and this is more compact. It's easier to look at this and see that's adding 1 to I. This takes more time to read because you actually have to look and see what the calculation is. And so we tend to use I++ for readability reasons, but you don't have to. It's a shorthand. Okay. Finally, we can do for loops in different ways. Here's a for loop which counts backwards by 2. It starts at the class roll size -1. It keeps going until it hits 0, and it subtracts 2 every time. You will almost never do this, right? But you can do lots of variations. Almost every for loop you write will look like that. It'll start at 0, it'll keep going until some maximum value, and it'll add 1 every time you go around. So if you really only need to memorize this one, but you know, you should know that they can be more flexible, and you can do other weird things with a for loop if you want. Okay. And we're right out of time, and I've got another class to get to. Thank you all for coming. Thank you all for being quiet and listening. I will see you on Tuesday, and hopefully we'll tell everybody who didn't come today to shut up on Tuesday. So, because obviously you guys like listening. Thank you. See you later. Go watch The Blues Brothers. It's a great movie.